Of course you punched the board. You're going insane.
I did that yesterday. That was a good demonstration.
You punched the
was
board
yesterday, right?
again?
This was today.
This was today?
Yeah.
Oh yeah, there you go. He's 6. Yeah. He's 6 today. I pointed out that, as Ella said, I have a very precise personality. Like I like things just right. So I showed B6. I'm like, look, don't be doing this. You're like, oh, that was actually good. I can't do it bad anymore. That was kind of weak.
Yeah.
Like that's an imprecise slap. Don't do that. If you want to have a good effect, like precise slapping, like that. That was good. Okay. Rotten, you know. I can't do it bad. There we go.
You gotta hit the side of the table first.
Oh, don't do that. Painful. I've tried it. Don't do that.
I thought you were going to do it to like
I
prove
got
a
really
point.
excited once. You guys got me all wound up. I hit it so hard, the thing shattered. Shrapnel everywhere.
Okay, wait, that one's fair because I've also done that.
All right. Same as number 2. You must have this flashcard. We're trying to find a constant. They're asking me to find K. I'm going to ignore the fact that they want me to find K. When I make a flashcard note, the line means one side of the other. So one side says find a constant. The other side says ignore the constant, do something familiar. Somehow you'll find the constant. Question. You must have that flashcard in your deck or you don't get to retake the test. You must have that flashcard in your deck. You do not get to retake the test. That's why the cards are on the table. So please.
I thought you said that no problem was like any other problem, but then you then said I'd do it exactly like the other problem.
Yeah, you lucked out.
All right.
You're correct. I cannot tell a lie.
Thanks.
Ella's correct. This one's a lot like the other one. So I do the same thing. Limit from the left here. It's even 2. Wow. Show your hands. What's that? Come on, hands. Think with me. Don't just watch. What is the limit as x approaches 2 from the left of this function called f? What is the limit as x approaches 2 from the left? Let's go, Autumn. K, did you say K?
Yeah.
3 points. No, the mistake is this. I'm trying to find what I'm trying to find out what the value of f is when the x coordinate is slightly less than 2. So I can't look here because that's when the x coordinate is exactly 2. No worries. Who knows? Go ahead. Autumn can try again as well. It's fine. Oh, holiday is just a thing. Let's go. Cambria. Close. What Cambria did is she said, hey, I need to use this formula. Let's see. The numerator is factored. The denominator is also factored, so I can divide these factors. We talked in retake prep number 1 today that those two will divide to make 1 as long as x does not equal exactly 2. But when finding the limit, we don't have x equaling 2, so that's good. But we need to find out what this formula produces when x is close to 2. So we don't want to write down 2x plus 1. We want to write down 5. The value of the limit is 5. How many knew it? 2 points, 3 for Cambria. Anybody want to talk about it? Please.
I get that, but how come we wouldn't do the rest of the problem, or the rest of the equation?
The x minus 2 over x minus 2.
Yeah.
So,
Oh, because that divides to 1.
yes, Keane's asking, wait a minute. And it's what David just said. The formula f looks like this, Keane. It's 2x plus 1 over 1 multiplied by x minus 2 over x minus 2. And I'm plugging into this formula Again, don't cross this out. But I'm plugging into that formula an x value that is slightly less than 2. When I do that, Kiani, what will this become when x is slightly less than 2? This will become 0 over 0 when x is exactly 2. If x is a little bit less than 2, this will actually be something like this. Which is actually equal to 1. So you need to memorize that this will always equal 1 unless x is exactly 2. Can I answer your question? Anybody else want to talk about it? One good way to see if you are thinking conceptually instead of just memorizing the problem, raise your hand if you can tell me what am I going to write on the board next. Hands up. What am I going to write on the board next? I told the class one time, I said, if I get you to think like I do, you will pass the AP test. A girl raised her hand and said, that's the stupidest thing you ever said, Mr. Smith. So of course we pass the AP test when we think like you. Never mind, bad joke. David.
No, the limit is x approaches just over 2.
So I'm going to write down the limit.
Oh, plus 2.
Just over 2 is fine. As x approaches 2 from the right. Please show me your hands, as they say in Brazil. Levante sua mão. 2 points, 3 for David. Questions? Please.
Isn't it just 5 again?
Yep. Because we use the exact same formula.
Yeah.
Here's how the two problems. Oh, Lena, please.
So then we're bringing next because it will equal what? X equals 2, so it equals 5?
Really what you should conclude now is this. So Megan's question is, so what does that all mean, right? What that means is, if you're drawing a graph of f, you don't really know anything about all the points, but you do know that when x is really close to 5, really close to 2, there's a point whose y-coordinate is very close to 5. When x is a little bit more than 2, there's a y-coordinate that's very close to 5. We're supposed to figure out what's happening. Well, it's back to this. Look. I keep showing you this, meaning you should have this memorized.
No, you could just flip the tabs, right? And
How do we flip? They don't flip on this one.
Yeah, they
Try that.
do. You can just click it and drag it to the left. I don't know, dog. Okay. Never mind then.
Yeah,
But
with Chrome you can
really
do that.
bad. Dang.
Yeah, I
Wait,
agree.
what are you running this on?
This is just an Acrobat.
Oh, I thought it
Acrobat
was like
Reader.
on Firefox or something.
You're
I was
good.
like, come on.
No, I agree. I tried that actually. Because I'm with you. I wanted to move it. It's bugging me because I have to keep hitting
Yeah,
the
you have
tab.
to keep it, yeah.
You saw me, yep. I need to go to my desk and reverse it myself. Look, hey, look. Right here. The limit from the left must be the same as the limit from the right, must be the same as the value of the function right at x equal 2. So that's the part that's different about this problem. It does actually fit Ella's comment, 2 more for her, of why you can't just memorize the problems. If you had just memorized the problem, you say, oh, I'm stuck. Like, I did what I did in the last one, it didn't work. Because you got to remember, you've got to go check f of 2. Hands up. What am I going to write here? Mike?
Would it be K or would it be pi?
I'm going to write k, because that's what I discover. Then I'm going to make the connection, which is if f is continuous when x equals 2, then all 3 of these values must be the same. That's how, 2 more for Ella Randall, that's how I stumble across the value of k. Like I don't solve for it, I just kind of find it. Please.
So I'm just kind of confused why you plug in 2 for the formula that's on top. Because it says that x does not equal 2. Is that because it's approaching 2 and not exactly 2, or is it like?
3 points for Autumn. It's very good. You are correct when you. Okay, so Autumn's question was for the video. Wait a minute. Why are we plugging 2 into this? It says right here, don't use 2 for that formula. We actually are not plugging in 2. We're plugging in slightly less than 2 and slightly more. Because if we plugged in exactly 2, this would be 0 divided by 0, which would be undefined. But when we plug in slightly less than 2, this becomes 1. This becomes actually slightly less than 5. But limit means what value are you getting infinitesimally close to equaling? We are getting infinitesimally close to equaling 5. I don't know if I've answered your question though. Okay. Please.
Well, so if you are finding the limit of 2 though, because you have to make sure that it's equal so that you can like make sure that it's k, well, I guess in like a scenario in which you didn't just say, okay, then it's probably 5. But in that situation, you can't do that then. Because the limit is equaling to 2 would just, you'd be putting in exactly 2.
Be careful, 3 points for Ella. She's talking about the difference between what this means versus what this means versus what this means versus what this means. Points for the whole room. Please raise your hand if you know how to find what goes inside that brown box. Please raise your hand if you know how to find what goes inside the brown box. The fact that most people didn't raise their hand instantly is a problem. We've got to fix it right now. But that's super fundamental. How do I figure out what goes inside the brown box? Let's go start with.
Do like the limit with the 2 negative and limit of 2 positive, and if they're the same thing, that's what it is.
Perfect. To find the overall limit, you do not pay. Let me say back what he said for the video. Sorry. Stockton said, to find what goes inside the brown box, I look at this, the left-hand limit. I look at the right-hand limit. I do not look at x equal 2. Absolutely not. That is wrong. I look at those two and compare them. These are the same. This is the same. These are different. This limit will be non-existent. So don't be looking there.
And the function not continuous, correct?
If these two are different, there's a jump, and the function is definitely not continuous.
So are you just averaging it?
No. I'm saying that when x gets, so the question was, am I averaging? No. When x is getting really close to equaling 2, but x is slightly less than 2, I use this formula. And I find out, like I said to Autumn, that this is 1 exactly. This is going to be slightly less than 5, but infinitesimally less than 5. So limit means what are you infinitesimally close to? We are infinitesimally close to 5. Same thing here. That means these two limits are exactly the same. Not kind of the same, they're exactly the same. They're exactly the same, this is the same thing. Anybody else? Please.
So what if it had been a removable discontinuity?
So what's actually happening, so Alice's question is, what about a removable discontinuity? This particular piecewise function, actually everyone can answer this for bonus points. Everyone can answer it. We just figured out that if k equals 5, this function is now continuous at x equal 2. That's what we just figured out. If k equals 5, this function is continuous at x equal 2. This is a simple question. All I want you to think with me, raise your hand, collect points. If we set k equal to 3, raise your hand, don't say it. Is the function continuous? Hands up. If we set k equal to 3, is the function continuous? Let's go, Marissa.
It's not?
It's not. How many agree? 2 points, 3 for Marissa. If k equals 3, if the function is not continuous, that means that at x equal 2, there is some type of discontinuity at x equal 2. Show me your hands. What type exists? If k equals 3, what type of discontinuity would we have at x equal 2? What type of discontinuity would we have at x equal 2?
A removable.
A removable. Because a removable occurs when the left and right limits are the same, but the value of the function is different. And since the value of the function is k, we choose k to be anything but 5, we actually cause a removable. Is that your question? Kind of.
I don't know, but
All right.
sure.
So you're good?
Yeah.
Okay, awesome, 3 points.
So I wrote down this phosphor and I just want to make sure it's correct. So F is continuous if the limit from the left and the right equal the value of F of X at that point.
Yes, just look at your reference sheet that you have in the sheet protector, and that's the box you're trying to make the box plot for. Perfect, 2 points. Okay, cool, another question. Here we go.